Everyone. Agenda for today's lecture video: linear regression. So linear regression is one of the topic in machine learning. There are three different approaches through which machines can learn: supervised, unsupervised, reinforcement. We will look at that one by one. Supervised learning. A supervised learning is where you have input variable x and output variable y, and you use an algorithm to learn the mapping function from the input to output. So the function y is equal to f of x. Here you can see that. In another way, we can say that x is independent variable. Based on the x, we need to find out output variable. If you supply x as an input to the machine, then automatically the machine predicts the output variable y. Before that, we need to supervise. That means supervise is nothing but a teacher teaching the class. So whenever a teacher is there, the teacher is always guiding the students. So for this is the answer. For this is the answer. So likewise, in supervised learning, there is a supervisor always teaching to the machine. So for input variable x, that means for the independent variable x, there is a dependent output. On dependent output means the y is dependent on x. Based on the input supplied to the machine, the output will be generated. So right, and the goal is to approximate the mapping function so well. That means the prediction, we need to find, we need to make sure that the prediction is accurate. When you have new input data x, that you can predict the output variable y for that data. And unsupervised learning, here you can see unsupervised learning is where you have only input data x, no corresponding output variable. That means in supervised learning, you can see that there is input variable and there is output variable also. That means we are training the machine based on some input variables and some corresponding output variables. But here in unsupervised learning, there is no output variable. We are only giving data to the machine. See, these are the images that we are supplying to the machine. So there is no label for these animals, right? There is no label, but the machine itself has to find the hidden structures in the data by itself. See that? Supervisor learning, there is, unlike supervisor learning, there is no teacher to provide. That means no training will be given to the machine. Therefore, machine is restricted to find the hidden structure in unlabeled data by itself. And another one is reinforcement learning. This is beautiful. Reinforcement learning can be thought of as a hit and trial method of learning. The machine gets a reward or penalty points. So machine will keep on learning based on the experience that experience. That means when the reward point is when it gets the reward point, then the decision that took by the machine is right. So it will consider that if the decision, if it gets the reward points, so automatically what it will think that the decision that it was made is correct. And if there is a penalty point, then what it means, the machine learning from the past experience. If it gets the penalty points, then it will get learn that the decision that it was made was wrong. So in future it should not make such kind of decisions. So here you can look at that. Machine learning algorithms. So in supervised, we can regression algorithms, decision tree, random forest classification algorithms, and clustering, association, hidden. You can see that. So these are the area dotted lines marked with the dotted lines. So these are the algorithms that deals with the continuous variables. And this portion, classification, association, and hidden, these are the marked lines that deals with the categorical variables. Now in data science, we have five kinds of problems. So to choose algorithm, so if the problem is this A or B, So we need to go for the classification algorithms. Is this weird? We need to go for the anomaly detection algorithm. How much or how many? That is a quantity, right? Continuous variable. Regression algorithm. How is this organized? Clustering. What should I do next? Reinforcement, right? These are the 5 kinds of problems in data science. So what do you mean by regression analysis? Regression analysis is a statistical predictive modeling technique used to study the relationship between a dependent variable and one or more independent variables. So dependent, what is dependent variable and what is independent variable? So independent variable means um, age factor, number of rooms. Okay, so based on that, otherwise square feet of the house. Based on that, the house rates will be decided, right? That means based on the number of rooms that it has and the number of air conditioners that house has and the square feet of the house, so decides what price of the house. So price is dependent on these three variables, right? So here you can see regression analysis is a statistical predictive modeling technique used to study the relationship between dependent and independent variables. So using regression analysis, what we are going to do is we need to study the relationship between two variables. That means one is dependent variable and another one is independent variable. So if you, whenever you supply an independent variable, so regression analysis will do the prediction according to the statistics and it will give the relation and whether the relationship may be in the positive side or the relationship may be in the negative side. So types of regressions. There are many regression analysis techniques, but the following three are most widely used regression models: linear, logistics, polynomial. So linear regression and polynomial regressions are dealing with the continuous variables, and logistic regression is dealing with the categorical variable. In our lecture video, we are focusing on linear regression. So what is linear regression? Linear regression is used to predict the value of an outcome variable y on the basis of one or more input predictor variables. In other words, linear regression is used to establish a linear relationship between predictor and a response variable. Right? Here you can see that linear regression is used to what? Predict the value of an outcome variable y. So in the linear regression, what we will do is we need to predict the output variable based on the input that was supplied. So the input variable may be one input variable or the input variables may be one or two or more variables. If we are dealing with the one variable, that comes under simple linear regression or single linear regression. Otherwise, if we are dealing with the more than one variable, so that comes under multiple linear regressions. So in this linear regression, what we are doing is we need to find output variable y based on the input variables. So selecting an input variable is also an important thing, because when you want to predict the temperature of tomorrow, so we need to find out uh, yesterday's temperature of sun, right? But not the temperature of our body. When you wanted to predict that temperature of a tomorrow's, then we need to concentrate on temperature of sun, not the temperature of our body, right? So temperature of our body is a not suitable variable for not suitable variable to predict the temperature of a sun. So selecting a input variable is also an important factor here. So how to select the suitable variable. We will look at that also. This is the mathematical equation for linear regression. You can see that this is the uh, dependent variable. So dependent variable is equal to beta 1 plus beta 2 x. X means what? Independent variable plus error rate, where beta 1 and beta 2 are combinedly called as regression coefficients, and E is the error term. You can look at that. Beta 1 is called as intercept and beta 2 is called as slope. Look at this diagram here. Here in the on the x-axis we plot independent variables, that means x variables, and on the y-axis we are plotting what? We are plotting dependent variables. In our data set we have while training the machine we have uh, input variables and as well as output variables. While training, we need to train the machine with input variables and along with that corresponding output variables. When I draw that graph, so the graph maybe looks like this, and this is the intercept beta 1, and here beta 2 is the slope of that straight line. So how linear regression works, we will see that with a small example. Look at that example. I have a data set. The data set contains area and rent, and the area is the input variable and rent is the output variable. That means area is an x and rent is y. So y is equal to f of x. We need to find out the function for that, right? So this is the data that I am going to train my machine. So for this input, this is the output. I am telling to the machine as like a teacher, as a supervisor. I am training my machine that whenever you got 1 as an input, so you need to tell 2 as a rent. Whenever I supply 2 as a input variable, then you need to give output variable as y. So like this I am training my machine. So then after I need to plot those values on x and y axis. This is the input variable and this is the output variable. So look at that. These are the points on the plot area. So now I need to find out the mean values of input variable and output variables, right? The mean of input variable is x, the mean of output variable is 5. So 3 comma 5 is another point on the plot area. So 3 comma 5 is the mean of x and y, input variable x and output variable y. So whenever you are drawing a line, so that line, the best fit line should passes through the dot of mean dot. This is the mean dot of area and rent. That means 3 comma 5, right? 3 comma 5. So the best fit line always has to pass the relationship, that this is the relationship, right? The best fit line always passes through mean point. So we can draw a number of lines like that, right? So which line is suggestible? We can draw a number of lines. So which line is suggestible means the line that is giving less error rate. So how to adjust that line? Using regression coefficients. So sorry, using residual coefficients. So see that these colored dots are actual points of see that on the x-axis area is there and y-axis rent is there. For this area, these dots are representing rent, right? These dots representing rents. These are the actual rent variables from the data set, and the black colored lines are the values that was predicted by the machine. So these are the black color dots that are predicted by the machine. So we are drawing a straight line by combining all these dotted lines. So how do you select it from many number of lines to that line? That, and I am saying that line is the best fit line. So the best fit line, what I said, the best fit line gives a less error rate, right? Error value. So what is error value? So here you can see that the difference between actual and predicted values, the difference between actual and predicted values, whenever the difference is very less, then choose that line. That line is the best fit line for our linear regression. So how to adjust that? Using residuals. So how to calculate that residuals means, as I said, y predicted y actual values minus y predicted. That means actual rent values minus predicted rent values. That is the difference. So that is the residual. So we will try to build a linear model. So a linear model is built using LM function, and LM is a function that takes two arguments. One is formula and another one is data frame, nothing but a data set. So I will try to open my R environment here, R Studio. So R was opened. Nice. So first what I do is I will load my data set into our environment. My data set is available in mm, F drive with the name houses. You can see that the data set is available in CSV format. Open with notepad. You can see that price, lot size, age, age of the house, land value of the house, living area of the house, number of rooms in the house, and total price of the house, right? So in our lecture, we try to find out the price value of the house using linear regression. So try to load this data set into our environment. So how to load CSV files? Using read.csv, right? Read.csv, and that was available in F, right? Houses. So make it in double quotes. So store the result of this statement in one variable. That variable is dt, data, that stands for data. Run that. Error in file RT cannot open the connection and addition warning message. No such file or directory. Why? We have just seen, right? F drive. Oh, I should give dot extension. So this is the escape character. To nullify that, again give one more escape character, enter. So data frame is ready. So this is the data, and if you want to see the data, so I don't want to see all the data present in the data set. I wanted to see just head section, and it will print 6 records. So that is the data available in DT. That means DT, using read.csv, what we will get? A data frame, right? So that is the data frame that we have. So based on the data frame, we need to train our machine. So here what I will do is I have only one data set here, but I need two data sets. That means one data set is for training purpose and another is for testing purpose, but I have only one data set. So what I will do is I will try to divide this DT frame, DT data frame into two partitions. So one partition contains 80% of the data and another partition contains 20% of the data. So for that I'm using set.seed function that will generate a random number, set.seed, and I need to use a function called sample.split. So the sample.split function is available in CA tools package. So I need to load that package, and before loading that, what you need to do is you need to install that package. I already installed in my system, so no need to install it again, but I am loading it, needs to load it again. So that CA tools was loaded. So now what I will do is I am splitting the data SP. So SP is this variable that stores the result of the splitted as sample dot split. So the sample dot split takes data set as well as what data set is available in DT, right? And how much percentage you want to separation. So split ratio is equal to how much I want, 80%, right? For 80% I am passing 0.8. So means that 80% data is divided, and SP variable contains true and false data. 80% of data is set true and rest of the data is set false. So now we will get that 80% data where true is available. So data was SP was created, and now I am taking a variable training set. So training set, a variable called training set, using subset function. Using subset function I need to get I need to get what, DT, that means training set subset of from the data frames SP is equal to true. That means we are having in the SP what we have, trues and false, right? So from the data set SP contains 80% of the truths. So 80% of the truths will be subtracted and assigned to train set. Okay, right? So now I will take another test set also, test set. So remaining 20% of the data, DT comma SP is equal to false, right? So I have train set, see the data, 80% of the data is available in the train set, and test set also. So 20% of the data is available in test set. So now what we will do is we will use a function called LM. So right, LM is a function that stands for linear model. So the linear model uses what, two parameters in that. What is the first parameter? So I'm taking a variable called model. Model is already available, so that is here defined. LM model, right? That is the new variable. So what is the function LM? The first parameter is formula, right? So what are the variables that we have in the houses data set? in the houses data set we have. So before that we will see head of dt. So these are the variables: price, lot size, age, land value, living area, and rooms, right? So lm model, lm is a function. So I wanted to find price, and this is the function symbol. So if you want to make involve each and every variable, to find out the price, so you can use dot. Otherwise you can if you wanted to remove any one variable, that means if you think that age is not affecting the price, age of the house is not affecting the price, then you can simply remove this. So we will see that I'm adding individual variables: lot size plus age of the house plus land value plus living area plus rooms. So this is the function, and it will take another parameter also, right? Data is equal to, so what is the data? dt. So data is available in dt variable, so that is the data frame. So from that dt we are constructing this formula using linear model. So we will print this thing. So our model was trained, our model was done, right? So but what I did here is I supplied data is equal to dt. That means 100% of the data I have used here. 100% of the data I have used here. But what I need to do is I need to supply only training data set, right? So training tr train set. Using this train set I am training my model. So model was trained now. So if you wanted to see the summary of that model, look at that. This is the summary of the model. You can see these are the residuals. Using these residuals we are fixing that a specific line, and these are the coefficients. So this is the intercept. That means the intercept means beta 1, and these are the values of standard error. This is the t value and probability of getting t. And here you can see that these are the star marks. So while teaching that dependent variable and independent variable, how to select a variable. So how to select a variable means the 3 stars indicates, so price is dependent on, strongly dependent on living area, and the price is strongly, that means 99.9% price is dependent on living area, 99% of price is dependent on land value and age of the house. And here you can see that lot size. So lot size, it is giving only 2 stars. If you have any doubt on the star ranking, that means 3 stars indicates 99.9%, 2 stars indicate 99%, 1 star indicate 95%. What is that percentage indicates means 95, 1 star gives 95% of that output variable is dependent on uh, lot size. If it is 1 star, so here we are having 2 stars, right? So 2 stars means 99% the price value is dependent on lot size. Here you can see that rooms doesn't have any star rating. That means room is not participating to decide the value of price. So we will remove the unnecessary values from the function here, from the function, right? So rooms, number of rooms are not affecting. That means it matters only living area is the matter, sorry, uh, and land value is the matter, and age, when that was constructed, number of years, how old that house was, and lot size is important, and number of rooms are not affecting the price, house price. So we will remove that. Here you can see so many values. Also here you can see the probability of t, and here you can see p value. So these are very very important. Look at that, these p value, and this here also p values are important. These p values must be less than 0.05 always. So this one is not affecting, means based on 0.01. So these are, you can see that 16 zeros, right? 2 e power minus 16, 2 e power minus 16. So that means that is very very less than 0.05, right? But here you can see 0.12. That means the value decides whether this variable decides the value of price or not. And you can see residual standard error here, and adjusted r square, right? F statistics, this one is also important here. So the F statistics value has to be in higher. So linear regression model was done. That model was trained using what? Using trained data set. So we need to test that model, right? So before testing, if you are not understanding what is the correlation between, here you can see that correlation between rooms and price, living area and price, land value and price, the correlation, if the correlation is very strong, then the deciding factor, that means price, is giving accurate result, price value will be accurate. So the correlation between two values must be very good. So how to find the correlation? You can find the correlation using, you can see here, using these dots. So here we can expect 95%, sorry, 99.9% of the correlation, and strong correlation, and here you can expect 99% correlation, strong correlation. So if you doesn't understand using these representation, we can do what? We can do a correlation plot also. So using that correlation plot, you can graphically see the relation between the variables. So how to see the correlation plot? How to do the correlation plot means, again, Control L. For this, you need to install another package called correlation plot. So I already installed that thing, and now what I am doing here is library correlation plot. You can see that I'm loading that package. So package was loaded. So now what I do is I am taking a variable called CR, that means correlation. COR is a correlation, and I'm passing DT, data frame, here. So using COR, I can find out the correlation between the variables in the DT. So I will print CR here. So this is the output that comes from the CR. That means this output is giving some information, some insights. So we cannot find out that such kind of insights by looking at the data, but we can visualize this data to find the insights. See that what is correlation, we will see. So look at here. Correlation is a statistical measure that suggests the level of linear dependence between two variables. So linear dependence, the level of linear dependence, how much level? 90%, 99%, 95%, 0. So correlation takes values between -1 to +1. If correlation value is closer to 1, then there is a high positive correlation between dependent and independent variables. If correlation value is closer to -1, then there is a high negative correlation between dependent and independent variables. Negative correlation means uh, the other value does not giving any effect on the first value. That means what? Independent value doesn't affect the, doesn't uh, consider the, sorry, the value of x, the value of x not giving any effect on the value of y. That means independent value x doesn't give any effect on dependent variable y. So y doesn't depend on x when there is a case of -1 situation. Correlation value is -1. You can see here, you can see, so there are many minus symbols, right? There are many minus symbols. So we will see that in a graph. So if you want to have any help regarding core plot function, you can just use help. We'll open, done. So here you can see that the help section. So chord plot function takes these many number of parameters. So we will use correlation. That means in our case that was CR, and method, the default method is, and circles, and type, that was lower, upper, or full. So we will use these three parameters here. So I will use CORR plot. I am plotting that CR. So CR is the value that contains data. So I'm using a method number. Method is equal to number, right? Here you can see that method is equal to number, right? And type is equal to, I am selecting lower. Run this thing. You can see that, this is the correlation plot. So here you can see price is dependent on price rise. So for all the values, lot, age, for all these you can get 1. So what here is the matter is the land value 0.58. So land value is one good thing that affects what? Price. And one more, living area. Living area is one good variable that gives a positive correlation. And rooms, here you can see that we cannot find number of rooms here. Summary, you can find summary of what is our model, LM model, right? So here you can see, here this model says rooms are not affecting the price, but according to this diagram, where is that? Yes, according to this we can say that rooms are affecting the price, and age is not affecting. You can see red colored, right? Red colored, and that was hidden. So hidden means those values are not affecting the price. Lot size also, we will see that in another way also. That means we will change that to full. I will change the type is equal to full. Here you can see, so this is the actual graph. So here price is dependent on land value, living area, number of rooms. Okay, So you can see that using another method also. That method is shape. I think shape is right. No, so I will take the help. So what is the method? Square, ellipse, number, shade. Okay, shade. You can see that shade. So Thus, this color indicates strong correlation. This color indicates strong correlation, and these are the red lines. These red lines indicates uh, strong negative correlation. So we should not consider these values according to this. So right, I will go with that. So I have founded the correlation variables. Now from according to the suggestions of correlation factor, so I will consider only few variables in my function LM model function parameter. So right, I will go with here. You can see that. So LM model, LM price, lot size, age, land value, living area, and number of rooms. So land value, living area, number of rooms are affecting. Lot size, I'm deleting this lot size. According to the correlation factor, lot size is not affecting, right? So we will see one more time. So lot size is not giving any effect, and age is also not giving any effect, right? So age is giving negative. So we will remove that age also. Actually in our data set there is no age. Yes, right, good thing. So I will execute this thing. So LM model, now we will see the summary again. So summary of the new trained LM model was done. So here also there is, it is again saying that rooms are not giving any effect, and living area, land value. We'll try to remove that rooms also. So land value and living area. Right, so these are the strong correlated values on price. So these are indicating star marks. You can see that here you can see F statistics 588.9 when there is a participation of rooms variable. Here you can see that 882.5 after removing the what rooms variable from the formula. So always F statistics value has to be high is better, and p value must be what 0. Less than 0.05. So now the question, we need to train this model, so we need to test this model, right? So how to test that model? So I will take predict function. Here you can see predict as a variable. I'm using predict function. So my model supplying, giving my model, trained model, and we have another data set, that is 20% of the data set is available for us, right? So that means train set. So I'm testing this. So I got the predicted values. So PRED, these are the predicted values. So right, so prediction also done. Now the thing here is we need to calculate the accuracy of the model. So first what we have done, we have trained the model and we have tested the model. We got the predicted values. These are the values of y. That means these are the output values, and you can see that the last record is 1400. This is the record number 1400. The record number 212567 is the house price. So right, this is the predicted values. So we need to calculate the accuracy. So for accuracy we need to go, we will see how to calculate the accuracy of a function, right? For that, so I'm taking an example here. This is the example, and consider this. We cannot explain with the huge amount of data, right? So if this is the weight and this is the height in a training data set, so this is the value, these are the values of weight and these are the actual values of height. So here you consider weight is the x variable, that means weight is independent variable, and height is the y variable, that is dependent variable. So in order to find out the height, we need uh, as an input weight is weight. So after prediction, I got this, see that. So predicted, these are the predicted values, these are the actual heights, these are the predicted heights. So if you supply 54, actually the actual height is 150, but the machine is giving 160. When you supply 61, the actual height is 170, but the machine is giving after many input variables, testing with many input. This is not, this is the single input, right? 61 is all the persons who are having weight 61 is not necessarily equal to 170 height, right? 170 centimeters of height. So it giving 180 predicted height. So you can see the difference is nothing but an error, right? So this is the predicted values minus actual values, or actual values minus predicted values. So the difference between actual and predicted is called an error. So now we have to calculate the error measure. For this I will follow three approaches. So one approach is MAD. So MAD stands for mean absolute deviation or mean absolute error. So the formula is sum of all the absolute errors values divides the actual number of values. See that, sum of absolute errors divides the actual number of values. How many actual number of values are there here? According to our example, 1 2 3 4 5 6 values are there. So sum of all these errors is divided by 6 gives MAD, that means mean absolute error value. So according to the formula, basing on our example, MAD value is 25. So what 25 suggests us? The 25 suggests that next time when I use this model to predict height, I may be off by roughly 25 centimeters, because height is 20 in centimeters, right? So 25 centimeters, and that may be prediction is 25 centimeters above the actual value or 25 centimeters below the actual value. So the second model, the second approach is RMSE. So root mean square error. So here you can see that sum of all errors whole square divides n, and we are finding for the total value a root, square root. So according to the formula, RMSE is 28 for our example. So what it suggests, next time when I use this model, prediction height may be off by 28 centimeters, and these two are giving values, right? So these two are MAD and RMSE are giving a numerical values 25 and 28. So if I get the percentage, so how much percentage is my model accurate? So this one is important. MAPE, mean absolute percentile error. So here you can see errors divided by sum of errors divided by actual values and divided by n. So according to the formula, MAPE is equal to 17.64 for our example. Take an example. So that nearly equal to 18%. So MAPE mean absolute percentile error giving us what? The relative value in terms of percentage. So what it suggests, MAP, next time when I use this model, the predicted height, it may be off by 18%. That means my prediction is 18% or 18% below. So see that was beautiful, right? So if I get 118%, 118%, my prediction is correct. So that is good. Otherwise, 18% below means what? So 92%, sorry, 82% of my model, my prediction is true, right? That is also beautiful. So we will concentrate this, and you no need to worry about the formulas to calculate. There is a package called metrics. So the metrics package provides each and every function. For MAPE, the function is MAPE. Okay, and for MAD, the function is MAE. For RMSE, the function is RMSE. We will check the accuracy of our model. So first what I do is I need to load metrics package. Before loading, you need to install library metrics, could not find function, library libr. No, metric, there is no package called metrics. Yes, capital M. Matrix was loaded. So now I will calculate directly MAP, or otherwise we will see MAE. So MAE of what? So the MAE function takes two parameters, actual values and predicted values, right? So here also you can observe this. So we need to pass actual values and predicted values. By basing on these two values only, by basing on these two actual values and predicted values only, the three approaches were made. So we need to supply actual values. So actual, where I have my actual values in training data set, right? So train set, so select price, comma, predicted values are available in PRED. See that 44250.94. So that means a good value. So and next RMSE, same thing. So for RMSE, so that is the value. MAPE gives what? MAPE gives the value in percentile. MAPE, see that this is important for me. So the value says 0.27. That means when you are using LM model, so my model LM model to predict the price of the house, so it is 27% off. Actually not a good value, so we need to improve that value. So to improve that value, I need to give a bunch of data, much of data to train my model. So then I will get a good value, good percentage. And you can see that 0.27 means 27 percentage. So 27 percentage. Next time I use this model, it is off by 27 percentage. That means my model gives how much? 73% is correct. My model predicting 73 percentage. That means I am giving statistical significance, right? So statistical significance. Again you can see that I will show you summary also, summary of model. So while selecting this model, you need to consider these values also. So see that r squared value higher the better. So if you have r square value adjusted r square, so higher value is the better, 58%. Adjusted r square higher the better. So r square adjusted r square higher the better, 58%. And f statistics higher the better. So after removing we got 882.5, right? And you can see that standard error closer to 0 the better. You can see standard error here, STD error, right? Closer to 0 is better. And MAPE means absolute mean percentage, lower the better, 27%. That is not lower. If we can get 10% also, but we need to train the model with a huge amount of data. And MSC, lower the better, and higher the better, mean max accuracy. So MAP, I thought MAP is enough for my model. So this is the all about linear regression. So your after training your model gives how much accurate predictions, 70 what, 27 means, where is that, 27, 73% your model is predicting accurately, right? So how to predict? So how to predict means I need to give a new data set, right? I need to give a new data set. For that I will take the support of testing new values. Testing new values means I need to create a new data frame with new values. So these are my values. This has to be exact. So I will take these values, and I am creating a data frame here, a new data frame for testing purpose. So dt TES, I'm taking a variable called TES, data dot frame. I'm creating a data frame. So for data frame, these are the in my, there is no rooms, and living area is there, land value is there, and there is no age, and land lot size also, there is no lot size also, right? So land value is equal to compound function of, so land value 50,000 I'm giving, living area is equal to combined function, so living area is 150. So TES was a new data input variable is ready. So now I'm testing my model, LM model, sorry, predict LM model. Using this LM model, find out result for this data, TES data, right? So this is the price of the house, and this predicted value is 73% accurate. 73% that was accurate. And this is all about linear regression. And if you have any doubts regarding linear regression, you can comment below. So, and don't forget to subscribe this channel, and click on bell icon so that you can get new notifications about my lecture video.